We begin with the cubic function in its factored form. Here, p, q, and r are the x-intercepts, or the roots where the graph crosses the horizontal axis. The leading coefficient a is the most important factor for the shape. If a is positive, the graph starts from the bottom left and ends at the top right. Think of it as an overall increasing trend. If a is negative, the graph is reflected. It starts at the top left and ends at the bottom right. Understanding this end behavior is crucial for sketching the curve correctly. To solve an inequality graphically, we compare the curve to a horizontal line. First, we sketch the cubic curve and the horizontal line y equals d. The points where they meet are our critical values. If the inequality is greater than d, we look for the intervals of x where the curve sits strictly above the line. If it is less than d, we focus on where the curve is below the line. This visual check ensures you don't mix up your inequality signs. Let us apply this to a specific problem. We need to find where this cubic expression is less than or equal to 0. First, we find the roots by setting each factor to 0. This gives us x equals -2, +1, and +3. Next, look at the coefficient. Since there is no number in front of the brackets, a equals 1. Because 1 is positive, the graph will start low on the left and end high on the right. Now we sketch. The curve comes up through -2, turns down through 1, and finally goes back up through 3. We want the regions where the graph is on or below the x-axis. This happens in two places. The first region is for all x values less than or equal to -2. The second region is between 1 and 3 inclusive. We use less than or equal to signs because the original question included the equal sign. Now let's look at a case where the inequality is not compared to 0. We want to find where the function is strictly greater than 6. We define our cubic function as f of x, and look for where it lies above the horizontal line y equals 6. To find the intersection points, we expand the brackets and set the equation equal to 6. After rearranging, we solve the resulting cubic equation. Using numerical methods, or given values, we find 3 intersection points at approximately -0.52, 0.82, and 4.70. Looking at our sketch, the curve is above the line in 2 separate intervals. Therefore, our solution set is x between -0.52 and 0.82, or x greater than 4.70. Note we use strict inequality signs because the question used greater than. Let's solve a typical Cambridge-style question. We need to find the intervals of x for which this cubic expression is strictly positive. The roots are the values that make each bracket 0. So our intercepts are at x equals 5, x equals 2, and x equals -3. Since the coefficient of the x cubed term will be +1, the graph starts in the bottom left and ends in the top right. The curve comes from below the x-axis, crosses up at -3, reaches a peak, crosses back down at 2, reaches a trough, and finally crosses up at 5. Since the inequality is greater than 0, we look for where the curve is above the x-axis. This occurs between -3 and 2, and again for all values greater than 5. Our final solution uses strict inequalities because the original question did not include an equals to component. Even top students can lose marks on these questions if they aren't careful. Let's look at how to avoid the most frequent errors. The most common mistake is drawing the curve upside down. Always check the sign of the x cubed term. If it is positive, it must end by going up to the right. If you flip it, your solution intervals will be exactly opposite to the correct ones. Pay close attention to the inequality symbol in the question. If the question uses greater than, your answer must use greater than. Including an equal to sign when it wasn't in the question is an immediate loss of marks. It sounds simple, but in the heat of an exam, students often shade the region below the axis for a greater than problem. Always write down above or below next to your sketch to keep your logic straight. When a solution has 2 separate parts, you must present them as 2 distinct intervals. Do not try to combine them into one long inequality chain, as that is mathematically impossible for these shapes. To secure those top marks in your IGCSE exam, follow these practical tips. First, always draw a sketch. Even if the question doesn't explicitly ask for a graph, draw one in the margin or the workspace. It is the most reliable way to visualize the regions and prevent silly mistakes with the direction of inequality signs. Second, label your intercepts clearly. Clearly marking your roots on the x-axis helps the examiner follow your logic. It also makes it easier for you to write down your final intervals without misreading your own handwriting. Third, test a point if you are unsure. Pick a value for x in one of your solution regions and substitute it back into the original expression. If the result satisfies the inequality, your region is likely correct. Finally, watch for the coefficient of x cubed. In some questions, the brackets might be arranged like 3 minus x. This introduces a negative x term. Always mentally multiply the x terms together first to determine if the overall cubic is positive or negative. It is time to test your understanding. Please pause the video and solve these 3 questions before continuing to the solutions. For the easy question, solve x minus 1 times x minus 2 times x minus 3 is greater than 0. For the medium question, solve x plus 4 times x plus 1 times 2 minus x is less than or equal to 0. For the hard question, solve x times x plus 2 times x minus 2 is greater than or equal to 3x plus 6. Take your time with the sketches as they are the key to getting these right. For the first question, we identify the roots at x equals 1, 2, and 3. Since the leading coefficient is positive, the curve ends by going upwards. We are looking for where the curve is above the x-axis. Looking at the sketch, the positive regions are between 1 and 2, and everywhere to the right of 3. In the medium question, the roots are at -4, -1, and +2. Wait, notice the last bracket is 2 minus x. This means the coefficient of x cubed is negative. The graph starts high and ends low. We want where the curve is on or below the x-axis. The graph is below the axis between -4 and -1, and again after x equals 2. We include the endpoints because of the less than or equal to sign. For the hard question, we first find where the curve meets the line. Expanding and rearranging gives us x times x squared minus 4 equals 3 times x plus 2. Moving everything to one side allows us to factor out x plus 2. This simplifies to x plus 2 times x squared minus 2x minus 3. Finally, we get x plus 2, x minus 3, and x plus 1. The intersection points are x equals -2, -1, and +3. We are looking for where the cubic curve is, above or on the line. By checking the intervals between our intersection points, we find the cubic is higher than the line in these 2 intervals. To summarize today's lesson, the roots of the cubic equation are the critical values that divide your number line into different regions. A positive leading coefficient means the graph ends by going up, while a negative coefficient means it ends by going down. Always check this before sketching. The inequality sign tells you whether to look for the parts of the curve above the boundary line or below it. Use strict inequalities for greater than or less than and inclusive symbols for or equal to avoid losing easy marks. Visualizing the curve is much safer than trying to test points algebraically for every single region.